This is Mrs. Wainwright's Math Class, Chapter 2, Lesson 5A. Use mental math to divide with ending zeros, and we're going to divide using the cancel the zeros method. Our learning target, by the end of today's lesson, you should confidently be able to say, I can cancel zeros to make mental math division problems easier. The goal of today's lessons is to eventually be able to do this as mental math and do it in your head without pencil and paper. This works when you have basic facts that divide evenly with no remainder. So let's take a look at example number 1. Example number 1 starts with a basic fact, 28 divided by 4. Well, if I go through my 4 times tables, I get 28. Put my fingers up as I go. 4, 8, 12, 16, 20, 24, 28. I get the perfect exact number, 28. So 28 divided by 4 equals 7. Let's take a look at another problem that's similar to this. The next problem is 280 divided by 40. Well, I know my 4 times tables, but I don't know my 40 times tables. And when I have partner zeros, that means a zero at an end zero on each number, both the dividend and the divisor, they're partners, I can then cross them out. So I notice that 280 does have an ending 0. Let's see if my divisor does. Does 40 have an ending 0? Yes, it does. So these two are partner ending zeros. And when you have partner ending zeros, you can cancel them out. Cross them out, it's like they're not there at all. They're never going to come back. Now I simply have the basic fact problem, 28 divided by 4, and I know that 28 divided by 4 equals 7. So 280 divided by 40 is 7 as well. What if I have this next problem, 2,800 divided by 400? Well, let's see. For a problem like this, I'm going to do one set of partners at a time. So 2,800, my ending 0 is right here, and my ending 0 and 400 is right there. There are partners because there's one on each side. I cancel them out. But wait, I see that there's more partner zeros because now I have 280 divided by 40, and in 280 there's an ending 0, and in 40 there's an ending 0, and those are also partners, so I cross them out. Now I simply have the problem 28 divided by 4, which equals 7. And let's take a look at the next part of this problem, something else that may come up as well. Here I have 28,000 divided by 400. So I'm going to see if I have ending partner zeros. In 28,000, my ending 0, my last 0 is here, and there's a partner ending 0 in 400. Cross them out, they're gone, they cancel each other out. Are there any more ending zeros? Well, now my 2,800 still has an ending 0, there it is, and my 400 has an ending 0, there it is. Those are partners again, they can get crossed out. But now my 280 that I have left still has an ending 0, but is there a partner for it on the 400 side? No, there are no more zeros left. So that 0 does not have a partner, it cannot get crossed out. So what I have left in this problem to solve is 280 divided by 4. I'm going to rewrite that so that that comma doesn't confuse me. I have 280 divided by 4. Again, no partners, therefore there's nothing to cancel. So I'm going to, at this point in time, I'm going to divide my basic fact. 28 divided by 4 equals 7. And then I have one ending 0 right here that I can tack on. So if there are partner zeros, you cross out the partners. But if there are no partner zeros left and you have an ending 0 in the dividend, that ending 0 can get tacked on at the end. So I'll take this answer and move it up to my answer line. 28,000 divided by 400 equals 70. Please stop the video and complete worksheet number 1 right now. Let's tackle example number 2. The problem here is 200 divided by 50. And again, anytime I see partner zeros in division that are ending partner zeros, I need to cancel them out. So in 200, my last 0 is there, and I see a partner for it in 50. So those are ending partner zeros, they cancel each other out. Now I have the problem 20 divided by 5. So maybe I can do the basic fact 2 divided by 5. But does that work? If I go through my 5 tables, am I going to get to a 2? 5 up too high, and I can't have a remainder, so no, 5 does not divide evenly into 2. What should I do? So if that doesn't work, then what I need to do is I need to extend my line and make it 20. Does 5 go evenly into 20? 5, 10, 15, 20. Yes, it does. 20 divided by 5 equals 4. So my answer to 200 divided by 50 is 4. Please stop the video and complete worksheet number 2 right now. Sometimes you'll see a problem that looks like this, 9001 divided by 300. And it's very easy to look at them and say, oh good, we have partner zeros, cross them out. But let's notice something about 9001. This 0 and this 0 are not ending zeros. And if they're not ending zeros, then we cannot cancel them. So it does not work. You'd have to divide this problem as a full long division problem to solve it. It would be 9001 divided by 300, and you would do it with full long division. And sometimes you may have a problem that looks like this. Problem number 4, 360 divided by 9. Oh good, well 360, I see there's an ending 0. But the problem is, there's no partner for it. There's no 0 in the number 9. So if there's no partner, then you cannot cancel it. What you would do here is your basic fact of 36 divided by 9 equals 4. There's one leftover 0 in my dividend, so I tack that 0 on to make my final answer 40. Please stop the video and complete worksheet number 3 and 4 right now. So to review this lesson, when you have a basic fact problem that divides evenly, for instance 28 divided by 4, you can use the cancel zeros method or the tack on zeros after you've done all of the canceling possible to basically divide with basic mental math. For instance, in 280 divided by 40, 280 has an ending 0, 40 has an ending 0, those are partners, so they cancel each other out, and we basically just divided. As long as there's partners on the opposite side, it doesn't matter how many ending zeros there are, you can still cancel them. So in 28,000 there's one ending 0 and there's its partner in 400. Now in 280 there's an ending 0 and we see the partner in 40, so all of those zeros are now canceled out, and again we simply divide 28 divided by 4 equals 7. And you can't just say, ooh, I can cross out all ending zeros, because that's not true. There have to be partners. So in 28,000 divided by 400, I have an ending 0 and an ending 0. They're partners, they're gone. An ending 0 and an ending 0, they're partners. I cancel them, they're gone. But I see here there's an ending 0 and there's not a partner for it. Therefore, I cannot cancel that. That has to stay there. So I rewrote the problem as 280 divided by 4, or I can simply look at it that way. And this will now be a basic fact problem, because 28 divided by 4 equals 7. There's one leftover 0, or leftover ending 0 in the dividend, and I can tack that on to my final answer, making it 70. When I have zeros that are in the middle of a number but are not ending zeros, I cannot cancel them. You can only cancel out ending zeros. And again, even if there's an ending 0, if there's no partner ending 0 on the other side, you cannot cancel it. You would just have to go ahead and divide your basic facts. Whatever ending zeros are left in your dividend, if there's no partners in the divisor, you tack them on after dividing the basic facts. And finally, be careful, because you can only cancel partners, and sometimes you'll need that 0, you wouldn't tack it on. For example, in the 200 divided by 50, I have partner zeros that are ending zeros. That leaves me with 20 divided by 5. But if I go ahead and solve it by saying 2 divided by 5, that doesn't work, because when I go through my 5 times tables, I never get to 2. So to solve this problem, I would have to say 20 divided by 5 is 4. I go through my 5 tables, 5, 10, 15, 20, that equals 4. And there are no zeros to tack on, because 20 divided by 5 was my basic fact. I've already used that 0. Remember, practice makes perfect with the tricks of this trade, so we will do some more practice problems in class. Good luck with this lesson.